Your motivation to learn is improved the more you learn. Now, researchers are finally learning that procedural pathway is also connected with our ability to use declarative learning. So this is why it's so important, for example, when you are learning math, or you're learning a language, or you're learning different artist styles, or you're learning music, you often first learn through the declarative pathway. You learn how to conjugate a verb, for example. But then you practice and you practice. And what that does is it sets a complementary set of links, neural links, related to the procedural pathway. It's not like you learn declaratively, create a set of links, and then move it over to procedural. No, you have to learn declaratively and learn procedurally, and that's when you really know something. Putting stuff in, trying to set a pattern. Diffuse mode is like, oh, okay, let's step back here and see if that's the right pattern. Is that the one that we should be laying? Or wait a minute, let's reinforce this part, but no, this part isn't quite right. So the diffuse mode, it also allows you to make unusual new connections, which sometimes need to be made when you're learning.
Welcome to Mentor Chat. In this episode, we're gonna learn about how to learn. You heard me right. And for that, we have someone special with us tonight. Joining us from the United States is Barbara Oakley. She is a professor of engineering at Oakland University in Rochester, Michigan. She has a MS degree in electrical and computer engineering and a PhD in systems engineering. Her work focuses on complex relationships between neuroscience and social behavior. She has published in various outlets like the Proceedings of the National Academy of Science to the Wall Street Journal. She also co-teaches a very popular MOOC called Learning How to Learn, which is, I guess, provided by UCSD. And it is a massive course. That is how I came to know about Barbara, and I thoroughly enjoyed the course. She has written a lot of books, and hopefully and I think she's also writing one more book currently. So that was about Barbara. So for me, the purpose of this podcast is when I started your course, as you also said in your speech, it was like knowing myself. So getting to know myself, and as a tool, when you know how a tool functions, you can use it more effectively. So that was what I gained from that course, and hopefully that is what I am trying to discuss in this course, getting to know your brain so that you can use it more effectively. You can learn a lot of things. I want to learn about your why, like how you ventured into this field and why you started this thing about learning how to learn.
Well, for me, I was a terrible student through elementary, middle, and high school in as far as math and science went. I pretty much flunked my way through. And I decided to study a language. I studied at the Defense Language Institute in Monterey, California, which is one of the world's leading language institutes. I studied Russian. And then I found out that I'd done everything people had told me to do. I'd followed my passion, but I followed my passion right into a corner because few people, at least at that time, were looking for expertise in Slavic languages and literature. And so I loved what I was doing. I became very good at what I was doing. And I was being selfish. I was only looking at what I was interested in. I wasn't looking at what the world needed. So I sometimes say, don't just follow your passion, broaden your passion. I mean, follow what you like, but also try to fit in some insights about what the world needs, because that's really going to help you in the long run. Because, well, I think it was the Queen Mother of England said once that work is the rent you pay for living. We all need to pay that rent somehow to give back by finding ways to help others through doing good work, whether it's at a hospital or at a school or at a car manufacturing facility or a salesperson. All of these kinds of things are really necessary. But I think that for me, what I became fascinated by is that some of the ideas and approaches and techniques I've used to learn a language well, as it turns out, are also extremely beneficial in learning how to learn things like coding and mathematics and chemistry and math and science in general. So I became very interested in helping people to understand that from a neuroscientific perspective, there's lots of good, practically useful insights that can help you learn more effectively whatever you're studying. So that's sort of my life's work.
So I just want to ask you about that. Does the concept of neurogenesis is how important is it? People, I guess, should know that they develop brain cells even if they are an adult. So can you explain what is that concept?
So you can. I mean, there's always the development. So all learning involves making connections between neurons in long-term memory in your brain. It does help when you have new neurons that are growing. That's particularly in the hippocampus is where that can take place. And these new neurons can help you to learn new things. But importantly, new neurons are growing and new neural connections can be made pretty much at any age. About the only time when maybe you're not learning is when you're in a coma or you're, maybe on your deathbed or something. You might not want to be bothering with learning new things, but rather putting together the things that you've already learned. But one interesting study found that older people, for example, in the 65-year-old age range, that there was one way that they could facilitate their getting back to the attentional abilities of when they were 20 years old. And that was to use video games, action style video games. So there's a lot of really good research that shows that attentional ability that you have to use when you're playing action style video games where somebody can pop around a corner and shoot you or something like that, even if it's pretend play, it activates all sorts of neural mechanisms that, in reality, on an evolutionary basis, we had to really pay attention if something could pop around a corner and kill us. And so when even in play, we're activating those sorts of same neurotransmitters, it can help improve our ability to focus and maintain attention. So anyway, even when you're older, you can still learn a lot.
Barbara, just a little thing. Can you speak a little bit louder or hold the mic closer?
Well, we've got this. How's that? Is that better?
Yeah.
Okay. We've got our mic in the picture. So it's magically here now. It will go boop.
No problem. It's fine. Yeah. So that, I think, serves as the motivation for the conversation that will follow, that you can basically learn at any age. So so before we begin the formal, the core discussion, I just want to make things clear is that what will be the span of the discussion? Like when you are trying to learn a skill, is it limited to just mathematical, logical, or is it also related to learning stuff which involves physical muscle memory for that matter, or let's say like playing guitar or learning some skills. So does it include that too?
Oh, you are such an intelligent man. Because that is a question that gets at a very deep and important aspect of learning. There's many ways we get information. I mean, ultimately, you need sets of links, connections between neurons in long-term memory to have learned anything. But there's several different ways to get that information in to create those sets of links. There's two very important pathways that can make that happen. One is the declarative pathway that goes through your hippocampus, and it's most of the stuff you learn in school, it seems. And it's called the declarative pathway because you can declare it. You are conscious of it. There's another pathway, that's the procedural pathway. That's where a lot of physical motion happens. So, for example, when you're learning to play a guitar, learning to ride a mountain bike, learning soccer moves, all of this kind of thing. And we used to think, oh, sure, there's that procedural. That's kind of for sports people. It's not the real knowledge there. Then they begin to realize, wait, no, the procedural pathway is quite important for habits and habitual action. So that's like when you're driving home and you start thinking about something and then all of a sudden you find your home. How'd you get home? You were using your unconscious procedural pathway, drawing on those sets of links. But now researchers are finally learning that procedural pathway is also connected with our ability to use declarative learning. So this is why it's so important, for example, when you are learning math, or you're learning a language, or you're learning different artist styles, or you're learning music, you often first learn through the declarative pathway. You learn how to conjugate a verb, for example. Then you practice and you practice. And what that does is it sets a complementary set of links, neural links, related to the procedural pathway. It's not like you learn declaratively, create a set of links, and then move it over to procedural. No, you have to learn declaratively and learn procedurally. And that's when you really know something. It's like having double sets of links to stand on so you can walk more easily. So this is why practice is so important. It helps you also develop those procedural sets of links, and that helps with virtually everything you're learning in any subject.
So what I get is that what you can say is that if you want, so the declarative thing is basically it is for you to make sense of what you are learning and about the connections, and second one, procedural, it brings it builds habits so that it then goes into subconscious. So am I right? So do I get it right?
Right, you're sort of making connections so things flow more swiftly. So, for example, if you practice with a lot of different, let's say you practice with problems that are involving the binomial theorem, the negative binomial theorem, geometric, distribution, all of these distributions, and you kind of practice in between them, your procedural system becomes much quicker with those ideas, and it's the one that learns the differences in the patterns through your natural practice. So this is important because when you take a test, they're not going to sit there and say most of the time, oh, for this problem, you're going to use the geometric distribution. You got to pick that out. And the ability to pick out which one you're going to use is something that only happens when you are practicing.
And another prerequisite, I guess, is the will to learn. So how much that accounts for in because many a times, like for school children, if a person doesn't want to learn, many a times it is the case that he still has to take the course. So uh, is it found that in that cases it is hard? So is there a correlation between your will and actually how you learn?
Yes, there is a correlation. And what happens is, okay, it's complicated, but your motivation to learn is improved the more you learn. So as you learn something, you begin to create what's called a schema. That's like little connections that help build your learning. The bigger your schema, the easier it is to stick stuff in it. There's like more stuff to stick to. That's why if you've studied some English, it's easier to learn a little more English. But if you haven't studied it at all, you don't, it's hard to get yourself even motivated to begin studying it. And that's where a good teacher can come in handy. But as it turns out, when you're learning something, if you are a little curious about it, the curiosity, the anticipation of having that curiosity satisfied squirts dopamine all over in various important places in the brain. This dopamine makes it easier for neural connections to be made and for them to be strengthened. So it's almost like fertilizer that comes out, helps that new stuff you're learning to stick. So having an interest in the topic definitely can help make interest or make your learning easier. How do you get the interest? Sometimes it's a question of kind of trudging through the very beginning of it when you don't have any knowledge of it at all.
So that makes a lot of sense. Like why when we are interested about some things, you learn faster. So yeah, that explains it. And now before we move on any further, like there is the two core things about two modes of learning. So can you shortly explain what they are for the benefit of the audience? The diffuse mode and the focused mode of learning.
So a lot of times when students are first sitting down to do something, so for example, for me, when I was first learning how to learn math when I was 7 years old, I couldn't figure it out. So I just thought, oh, I must be stupid. I don't have the math gene. And I gave up on learning math, which was, if I had known then what I know now about learning, I would have acted very differently, because it's actually quite typical for many people to simply not understand what's going on the first time they sit down to do something a little difficult. What you're doing is you're using like a part of your brain that you're focusing on the material. But let's say, I'm kind of using metaphor here, but actually the part of your brain you should have been using was over here. It's just a little bit of a different pattern. And so it's only when you try it, you bang your head against a wall, you give up, you walk away, you come back later, and magically behind the scenes, you have a different mode of thinking. That's the diffuse mode, or more technically, the default mode network. And this default mode network, it bounces around when you're not focusing, and it can settle on the right pattern that you should be using, or at least beginnings of it. So if you take a break, step back, let that other mode think in the background, as long as you've kind of prepared things by getting a little stuck, it will do the work. And then when you return, either later that day or the next morning, suddenly you'll go, well, this was so easy. Why did I even think it was hard? So that happens so often. And learning often involves this back and forth between focused and diffuse modes.
And so considering like these two patterns, like so whenever we say that we want to learn a thing, or suppose we are training in the gym, so recovery is as important as like actually working out. So does this need to happen in cycles for faster learning? The diffuse mode and the focused mode?
It does help, and it helps in several ways. It not only helps you to take a step back and then look with a fresh perspective when you're stuck on something, but taking little breaks when you're studying, what that does is it helps you to, your hippocampus and your neocortex are like two learning machines. Hippocampus is only temporary. Neocortex is where you want it to be. But that hippocampus, it's hearing, it's learning, and then it's turning around to the neocortex and say, guess what I heard? Remember, you heard it too, but I'm going to tell you again and again and again. And it does. But that hippocampus can only turn around and do that when it is got a little bit of a break. So if you do something like the Pomodoro technique, which is to get rid of all distractions, set a timer for 25 minutes, focus as intently as you can for 25 minutes, and then take a 5-minute break. That 5-minute break is one of the most important parts of that Pomodoro exercise, because what it does is it allows you to, your hippocampus can relax. It can offload stuff. You don't feel it, so you feel like you're not doing anything, but your brain really is helping that information to go into long-term memory. But if during that break you sit there, you go, I'm going to check my emails. I got to respond to Sam. You're focusing again, and you're not allowing that hippocampus to take a break. So when you do take little breaks, it's important to really take a break. Stay away from your phone and relax. You can't really feel it, but you can almost feel it. Something's going on there. It's starting to make sense of what you were just learning. And so I cannot emphasize these little sporadic breaks every 25 minutes or so when you're studying can be invaluable.
So whenever you are thinking in the focus mode, that is where the pattern is being recognized, and whenever you are in the diffuse mode, it is being learned. So whenever you are in the diffuse mode, actually the learning takes place. Is that what you want to say?
The diffuse mode is part of the learning process. So focusing is like putting stuff in, trying to set a pattern. Diffuse mode is like, okay, let's step back here and see if that's the right pattern. Is that the one that we should be laying? Or wait a minute, let's reinforce this part, but no, this part isn't quite right. So the diffuse mode, it also allows you to make unusual new connections, which sometimes need to be made when you're learning. Diffuse mode is more of it's a much more broad-ranging set of connections in the brain. Focus mode is often called by psychologists the task-positive networks. So you're actually working with a task in a particular area, whereas diffuse mode is you're activating much more broadly, and it's the chances of you making a creative new connection are better in diffuse mode.
So whenever we are learning things in terms of neurons, are these the only two things that are taking place?
Oh gosh. Even just doing that is so complicated. There's lots of stuff going on. And remember as well what I spoke about as far as, so we've got focused and diffuse, but we've also got those procedural and declarative pathways. And so we want to be mindful of these kinds of things. We want to be mindful of avoiding distraction insofar as is possible if we're really trying to focus down on things. Now, if we're trying to be a bit creative, then a few distractions here and there can be, I hate to say it, helpful. So for me, for example, when I'm writing, I'll often come up, I'm writing, I'm stuck on a sentence. I know that sentence is wrong. I can't really think of how to write it properly. And so I'll go off and whatever strikes and comes up on the internet. Or I'll talk to my hubby, or I'll, just whatever. That little break can get me out of the sort of the mental block that I had on that particular thing, and it can help me with moving past that block. So there's good research. There's something called attention residue, and that means when you're focusing hard on something, and then you're distracted and you have to move to something else, which is often what happens in business today. You're working on something, and then Sally comes in with some new information or something she's got to interact with you about. You're distracted. Part of your mind is still on what you are focusing on, and you turn to the other person, and then you're talking to them. So you are not as fully focused on the other person because you have attention residue from what you had been working on. So what they have found is a good thing to do whenever you're in these circumstances where you have to switch your attention sometimes to something else, try to, before you look up, try to go, oh, where am I on the page and what was I doing? How do I get back to what I was working on? If you make a little mental note that way, that gives you closure, and you are actually able to concentrate more fully on that other person. So that's a way of dealing with attention residue. But another thing that's sort of past attention residue is getting stuck on something where you're wrong. So, your attention's there, you want it to be there, but you're stuck. And in that case, kind of going off and being distracted a little bit sometimes can really help.
Right. And so is there any ideal time for the length of these cycles, or is it just subjective, like depends on the person?
So Anders Ericsson has found that generally people can work really intensely for 4 to 6 hours a day to do something that's really mentally taxing. That's not to say you can't work further than that. In medical school studies, they found that the best students who get the best grades generally study between 6 to 8 hours a day. But more than that, more than 8 hours, it doesn't really help. So that's as far as like in a day, how much can you concentrate? Right. But within a session, people's tendency is often to go, well, I'm going to study for 2 hours, and I'm going to study that entire 2-hour session. But if they instead study for like 25 minutes, take a 5-minute break, 25, 5-minute break, do that kind of Pomodoro approach to studying, it will help them much more than they had thought. Those tiny little breaks help your hippocampus to offload, help give you a fresh perspective and so forth. So I think taking little breaks when you are learning try it. You will find that you're actually more effective if you're studying for long periods of time.
Right. And along with breaks, sleep is also very important in the part of learning. So can you elaborate on the importance of sleep a little bit?
Well, sleep and exercise are both important. So sleep is important because your brain starts making connections during the day when you're learning. But when it really reinforces those connections is at night. So your brain will kind of it will run these signals over and over and over again, hundreds of times. And that really helps to build and strengthen those neural connections. To make that happen, it sometimes can help to think about what you're learning right before you go to sleep. In fact, Duolingo found that their best learners learn during the day and so forth, but they would review the material right before they went to sleep at night. That's their best learners. So we're talking hundreds of thousands of input. So sleep is very important in that if you don't get enough sleep, you don't have an opportunity to solidify what you learned during the day. And you're kind of wasting what you've learned because you've learned it, you spent the time, but then you didn't sleep on it and allow those neurons to connect strongly. And so, it's kind of a wasted effort in some sense. But also exercise is important because it produces this is one amongst many different substances, but there's a chemical called brain-derived neurotrophic factor, BDNF. That's one of the most prominent. And when you exercise, it produces BDNF in the brain. And this is kind of like a fertilizer that helps, again, for those dendritic spines to grow and make strong connections. So for years, they've always wondered, why is exercise important? Now they know why.
Okay. And then, like, now we have learned about how the brain, on a very high level, how it learns. But what are the barriers for people? Like, why do people stop at some point? Can you tell us something about that?
Oh gosh, there could be thousands of different reasons for people stopping to learn. Sometimes people get done with school and say, I'm done with learning. It's so funny. I just had a student from probably 15, 20 years ago contact me and say, I just got a new job. And the reason I got the job was that during this COVID epidemic, I've spent a lot of time online learning and taking classes. And that's actually why they hired me, was because I was fresh. I was really trying to learn something new. So I think sometimes it's simply a mindset of, oh, I'm out of school, I don't need to learn anymore, as opposed to, oh, I'm out of school, I want to keep myself fresh. And also, I want to broaden my horizons. Of course, we are lucky to be in an era where learning is so much more easily available. Sometimes people are in a very difficult situation and they have difficult lives, and so you can't blame them if learning is last on their list, because learning it's something that we are lucky to have. So I think it's important for us to cherish and take advantage of it if we're able to do that in our lives.
Right. And suppose if I'm interested in solving a particular thing and due to some reason I'm not getting it, so what is actually happening inside my brain? So I am feeling like to give this thing up and probably move to something else.
Oh, so that's it's a little bit of a hard question to answer, because sometimes people maybe they have a dream and the dream is just not the right one for them. But on the other, for example, I know a fellow who's very, very talented and is 65 and decided to become a doctor. And he passed all the tests, did phenomenally, all was all set. And then when he went in for the interviews, they said, do you really want to take this position because you're fully qualified, or would you rather give it to someone who's far younger and might be able to use it for their knowledge for far longer? And so he decided not to become a doctor ultimately, just in order to give to the younger generation. So I think that was, he made that decision, and it's based on, some good thinking. But many times we give up too easily. I think that what I often find is the people who are really successful are how can I say this? are the ones who early on seemed like they weren't as good. They were second
Mm.
best.
Right.
And I think it's if you are really good, you're cocky and you don't try as hard. And actually, it's the effort, it's the persistence that is what makes the difference. So it's the ones who think they're not as good, so they were not as cocky and they tried harder. And actually, that's what helped them to become successful, highly successful in the end.
Mm. So then, how does one train themselves to like focus for a long period of time? So we all know the Pomodoro technique, but for the audience, can you explain what the Pomodoro technique is and how it helps you?
Okay, so the idea of the Pomodoro is not to focus for long periods of times, but to break your focus up into little periods that ultimately will lead to what is the same as a long period of focusing. And with the Pomodoro technique, you first turn off all distractions. So nothing popping up in your computer, no little ringies on your cell phone. Turn that all off. In fact, if you need to, put your cell phone somewhere else. Like in another room, because it will help keep your mind off it. Then set a timer for 25 minutes. Any timer will do. I have one on my laptop. Focus as intently as you can for 25 minutes and realize that sometimes you'll be distracted. Oh, I'll think of this. Well, if it's something you want to do later, write it down and then just continue with what you're supposed to be doing. So try to bring your attention back to what you're doing. And then perhaps the most important part of the Pomodoro, the fourth part, is to take a break. So usually 5-minute break or so after you're done, and really relax. Go have a cup of tea, walk around. Try not to, if you do something physical, it's really the best. It kind of gets your blood moving and so forth. But this Pomodoro technique, it is so effective because it helps you to just work intense. It's kind of like an athlete where you work out really intensely and then you relax. And that is a really good
Right.
way to approach those kinds of things for athletes and as well as for mental athletes.
And if I'm not wrong, I think that it changes the focus from the reward to the time spent in solving the problem, and that is why it is beneficial.
You are so right. And that is a very good point, is you do not want to focus on like completing a homework set or on some task. You want to focus on the process. I
Right.
just have to do 25 minutes. That's all. And
Mm.
if you do that, it can help you. I mean, when you even think about something you don't like or don't want to do, it can cause the brain to activate, the insular cortex to activate, which is part of the brain that experiences pain. So don't think about what you got to do. Just sit and start doing it. And that will avoid that pain in the brain that can bring procrastination.
Right. And this concept, like, it really connects with your point of view that you don't know what your passion is unless you have tried difficult stuff. So that is why that beautifully connects